So this video is integrated 3. This is on the binomial theorem notes, which you should do after you have filled out your Pascal's triangle and watch the little video on how to fill that out. So this is Pascal's triangle here, and something that it's useful for is actually taking binomials like these down here, a plus b to the power 0, a plus b to the power 1, and so forth, and expanding them. So if I was to take a plus b to the 0, that anything raised to the 0 is a 1. So that represents this first row of Pascal's triangle. If I take a plus b to the first, that's really just a plus b. It's a 1a plus a 1b. So that represents the second row. When I say first row, I really shouldn't say first and second. This one's considered like your 0 row. This one is your first row. This one's like your second row. Okay. Now, if you take a plus b squared, a plus b squared is a squared plus 2ab plus b squared, and that corresponds with this 1, 2, 1. Now, if I was to work out a plus b to the third, working out a plus b to the third, I'm just going to do it over here. Just this, you don't have to write this down. I'm just going to do it just as an example. But if I was going to take, whoops, I get something smaller. If I was going to take a plus b to the third power, that is really a plus b times a plus b times a plus b. Well, this right here is going to be a squared plus 2ab plus b squared. That's a perfect square trinomial. And then I'm going to times that with an a plus b. So if I was to work that out, try to split this into 3, not into 2. I'm going to have a squared plus 2ab plus b squared, and here is a plus b. I'm going to multiply this together, and when I do, I get a to the third, 2a squared b, a b squared, a squared b, 2a b squared, and then b to the third. Now, when I combine like terms, I have an a to the third. I have 3a squared b because of this and this. I have 3a b squared because of those, and then I have my b to the third. Now, this one corresponds with the row right here, 1, 3, 3, 1. So if I'm doing a plus b to the fourth, instead of working all of that out, which means I would basically take this and times it by a plus b to get a plus b to the fourth, I can look at this row right here, okay, the row with 1 and 4 and 6 and 4 and 1, and those are going to be the coefficients in front of my variables. Now, what's going to happen is you always going to start with your a to the fourth, and again, there's a 1. There's really a 1 in front. Okay, I usually don't write with the 1, but I'm going to write the 1 temporarily. And what happens is it's a to the fourth and then b to the 0, where your a's are going to go down and your b's are going to go up. Plus, and then we're going to use the 4. So this is going to be 4a to the third, b to the first, plus, so now I'm going to use the 6a squared b squared, then my 4, so 4a to the first, b to the third, and then my 1, so 1a to the 0, b to the fourth. Now, a couple things I want you to notice. Let me zoom in here, okay? First thing I want you to notice is, again, I really could just write this as a to the fourth. I don't need the 1 and the b to the 0, plus 4a to the third, b, it's a b to the first, but I could just write a b, 6a squared b squared, 4a b to the third, and then this last one, the 1 and the a to the 0, those are just 1 times 1, so I just get left with b to the fourth. Now, what I want us to notice, however, is, look at these exponents. 4 plus 0 is 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 and 3 is 4. 0 and 4 is 4. Okay. And so then that is always going to be the case where these exponents are always going to be adding to this right here. Okay. That's going to always happen. So when we are doing this, another thing that I'm going to point out before I get into the main part of the notes is that when we're doing this, each of these rows is really combinations, okay? The combinations that we were working with the other day. So if I am looking at, for example, let's say this row right here, 1, 3, 3, 1, okay? Since this is a 3, okay, what this really is 3 choose, okay? Now, I like to start with my 3 choose 3, then 3 choose 2, then 3 choose 1, then 3 choose 0. Now, if I do 3 choose 3 in my calculator, what I'm going to get, let me just kind of color code these. When I work out 3 choose 3 in my calculator, 3 choose 3 is 1. Now, 3 choose 0 is also 1. Why? Because 3 plus 0 adds up to the 3. And so anytime those add up, they always are the same answer. And then this 3 and 3 are my 3 choose 2 and my 3 choose 1. If I put those in my calculator, 3 choose 3 is 3 choose 2, sorry, is 3, and 3 choose 1 is 3. Again, since 2 and 1 add up to the 3, they're going to be the same as each other. So some books will think of this as 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. I like to start with the 3 choose 3 because that helps me when I'm trying to think about these exponents here. Okay, I match it up with the bigger exponent. Okay. So that's something else I want you to understand. So again, if we're looking at this, let's say I am in this row here. Okay, the 1 and the 1, the 5 and the 5, the 10 and the 10. So what's happening here, and again, I'm just saying this to you guys don't need to jot this down, but this one here is really 5. Let me write it smaller. Let me get it thinner. Okay, so this one here is really, and you look at this, that number tells you what choose what. 5 choose. This one here was 3 choose. This one here is going to be 4 choose. So this is going to be 5 choose. And again, I like to start with my 5. This is going to be 5 choose 4. This is going to be 5 choose 3. This is going to be 5 choose 2. This is going to be 5 choose 1. And this is going to be 5 choose 0. Now, in this case, it's much easier to do Pascal's triangle just by adding up the terms from above than doing this a combination. But when they ask you for a single term in an expansion, then this idea is helpful. So I personally, if I'm filling out Pascal's triangle and I'm drawing it for myself, okay, and again, this is all just me, just kind of giving you some background information. I would just go 1, 1. Okay, always you start and end with a 1, 1, 2, 1, 1, 3, because I'm adding these together, add these together, 3, 1, 1, and then these add and give us a 4, these add and give me a 6, these add and give me a 2, sorry, 2, wow, a 4, and then we have our 1. So if I had to try to expand a whole polynomial like I was doing here, up here, I would just use Pascal's triangle to get my 1, 4, 6, 4, 1. 1, 4, whoops, 1, 4, 6, 4, 1. But I want us to understand that each row is also a combination. So if I'm down here, these are going to be 10 choose. The first one I would think of as 10 choose 10. Then the next one would be 10 choose 9, and so forth. Okay. So this right here is really like how you could go about doing it using combinations. This is really combinations here. This is really n choose n choose 1 less than n choose 1 less than that, and so forth and so forth and so forth. Now, what you'll notice is this here matches with this exponent. This here matches with this exponent. This here matches with this exponent. Okay. And that's why when I was writing this, I personally like to start with it being 5 choose 5 as opposed to 5 choose 0. So that 5 is going to match my lead coefficient's exponent. Okay. So let's try to do some expansion. Okay. So when I'm doing this, okay, and I was expanding this, okay, so let's say I was expanding this. Since this is a 7, I'd have to go to the row that had 1, 7, okay, so I know we have it here, but let me just again show us. This would be a 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, and now this is the one I want, 1, 7, because of that 7, 21, 35, 35, 21, 7, and 1. So that's the row I want to do. Okay. So I'm just going to jot this down. Whoops, not in highlight. Don't want to do it in highlight. I'm just going to jot it down in 1, 7, 21, 35, 35, 21, 7, 1. Okay, so that's what I want to be using down here. So I'm going to be using that when I'm expanding this. So what I'm going to do is I am going to start with my a to the biggest exponent, which is going to be the 7. Okay, so I'm going to have I'm going to just write smaller here. Okay, a to the 7th plus 7. So again, it is a 1 in front, but I don't need to write it. And it was a b to the 0, but I don't need to write that. So 7a to the 6th, which means my b is going to be the first because 6 and 1 have to add to the 7. This 7 plus, and I'm using the 21, a to the 5th. Again, it's going down 7, 6, 5. 5 plus what gets us 7? 2. So it's always going to add to this exponent. Plus 35. Now it's going to be a to the 4th, which means my b is going to be to the 3rd. Another 35 because I have 35 twice up here. So this is going to be a to the 3rd and b to the 4th. Plus 21, a to the 2nd, which means my b is going to be to the 5th because they always have to add to 7 if this is a 7. Plus 7, a, b to the 6th, really a to the 1st. And my last one's 1, b to the 7th. And that's my answer. I'm done. Now, this next one's slightly different because it's not an A and a B. We've got a 2x and a 5y. But I'm going to do the same idea. Now, in this case, this right here is a 3. So I'm going to be using the row 1, 3, 3, 1. That's the row I'm going to use. Okay. So I'm just going to jot that down for myself. So 1, 3, 3, 1. That's what I'm using. So what I'm going to do is my A or my lead is going to be this 2x. So I'm going to take that 2x, that whole 2x is going to be raised to the third power, plus 3 because of this 3. And now my 2x, that whole 2x is going to be raised to the second power. And my 5y is going to be to the first. So I'm going to have a 2x to a power and a 5y to a power, just like I had an a to a power and a b to a power. So I start with my 2x to the biggest power, 3. Then it's going to go down to a 2. Now 2 plus 1 gets me 3. And when I say 3, it's this 3 here. Okay. Plus, and now I'm going to use this 3. So 3 times 2x. This time it's to the power 1. And my 5y is going to be 1 plus 2. And then my 1, that's going to be my 5y. This time this is going to be a 3. So as you're looking at this exponents, my 2x is to the third, to the second, to the first, and then to the 0. And then my b is my 5y. I have no 5y at the beginning. Then it goes 1, 2, 3. Okay, so one of them's going down, the other one's going up. Now, this one I have to do a little work. I can't leave it like this. We want to clean this up. So here I'm going to take 2x to the third, which is going to be 8x to the third. Now here I'm going to do this math. I'm going to take 3 times 2 squared, which is 4 times 5. So 3 times 4 times 5. So 3 times 4 is 12. 12 times 5 is 60. So I have to do that math. Okay, so let me just kind of break this down. So this is really a 3 times a 4x squared times a 5y. We don't leave it like that, though. We do need to clean it up. And then this is a 3, and this is a 2x times my 5y's being squared. So that's going to be a 25y squared plus 5y to the third is going to be a 125y to the third. So let me clean it up. So 8x to the third plus, and again here, 3 times 4 is 12 times 5 is 60, x squared y. Over here I have a 3. Well, here, let me do this. 2 times 25 is 50. 50 times 3 is 150, x y squared plus 125y cubed. That is our answer. Okay, so this one is a 4, so I'm going to be doing the row 1, 4, 1, 4, 6, 4, 1. Okay. Okay, so 1, 4, 6, 4, 1. I can actually kind of see it up here from this one. Start with a 1, add these together 4, add these together 6, add these together 4, and end with a 1. Okay, now in this case, what's going to happen is my 2x is going to be one term, and then my negative 3y is going to be another term. So I'm going to be starting with my 2x to the fourth because of the power 4 here. Plus, and I'm going to have 4, because of this 4, times 2x this time to the third, and my negative 3y is to the first, plus 6. Now my 2x is going to be raised to the second, and my negative 3y is going to be raised to the second. Again, notice 4, 3 and 1 is 4, 2 and 2 is 4, because of this 4. Okay, plus, now I'm going to deal with this 4. My 2x is going to be to the first, and my negative 3y is going to be to the third, because again, they have to add to 4 those two exponents. Plus, and in this case, this is going to be negative 3y to the fourth. So when I'm doing this, this is going to be 2 to the fourth is 16x to the fourth. Here, this is going to be a 4 times 8x cubed times negative 3y. Again, not leaving it like this. I have to work it out. 6, and then this is going to be 2x squared, which is going to be a 4x squared, negative 3 squared, so that's going to be a positive. Let me try it again. positive 9y squared plus 4 times 2x. Negative 3y to the third is a negative 27y to the third. And a negative 3 to the fourth, that's going to give me an 81y to the fourth. So now I'm going to work this out. So it's going to be a 16x to the fourth. And I'm going to have 4 times 8 times a negative 3. I get a negative 96 x to the third y. Plus, here I have a 6 times 4 times 9. So that's going to be a 216 x squared y squared. Now here on the next one, it's actually going to be negative. It's going to be a minus. I have a 4 times 2 times a negative 27, which is a negative 216. That's why this is a minus, minus 216, x y to the third, plus 81y to the fourth. And just to color code, just to make sure everyone understands what's coming from what, this gave me this. This whole thing here gave me this. This whole thing here gave me this. And this whole thing, whoops, went too far. This whole thing here gave me this. And then this gave me that. So I should be cleaning all of these up to something that looks like this. Now, what I want you to notice is when you have a minus here like this one does, notice it's alternating signs, because what's happening is I have a negative to an odd, then a negative to an even, a negative to an odd, and a negative to an even. And a negative to an odd is always going to be negative, but a negative to an even is always going to be positive. That's why these are alternating. Okay, next one. So this one's going to be 5. So I'm just going to look at these numbers up here. Okay, so 1 and 4. So I'm going to start with a 1, and then 1 and 4 give me 5. 4 and 6 gave me 10. 6 and 4 gave me 10. 4 and 1 gave me 5, and then a 1. Okay, so that's the row I'm using. And again, we see it up here where I have a 1, 5, 10, 10, 5, 1. Okay. Now, in this case, I'm going to be dealing with a 3x, and I'm going to be dealing with a negative 4y each time. Okay. So I'm going to be starting with my 3x to the power 5. Now, plus, and I'm going to have 5 times my 3x to the fourth, and my negative 4y to the first, because 4 plus 1 is 5. Then 10, and then this time my 3x is going to go down to the third, which means my negative 4y, 3 plus 2 gets me 5, plus 10, because I have a second 10 here, and this time my 3x is going to be squared, which means my negative 4y is going to be to the third, because 2 plus 3 gets us 5, plus 5 times 3x to the first, and negative 4y to the fourth. Now, the next one, move it over a little bit, is my 1, and that's going to be my negative 4y to the fifth. Okay, so when I work this out, 3 to the fifth is going to give me 243. So it's going to be 243 x to the fifth. And I know it's going to be alternating signs. So this is going to be minus. And then let me just do the math. 5 times 3 to the fourth times times -4. So that gave me a -1620 x to the 4th y. Again, I'm taking 5, and then this 3 to the 4th is an 81, and then -4. Plus, here I'm going to have I'm just going to highlight a 10 times a 3 to the 3rd, which is a 27, times a -4 squared, which is a 16, and I get 4,320. So I get 4,320 x to the 3rd, y to the 2nd. Minus, because again, to be alternating signs. And this time when I'm doing it, I'm going to have a 10. I'm going to have a 3 squared, which is a 9. I'm going to have a -4 to the 3rd, which is going to be a -64. So I have a 10 times 9 times a -64. I end up with a -5,760 x to the 2nd, y to the 3rd. In my next one here, I have 5 times 3 to the 1st, and my -4 to the 4th. So that is going to be 5 times 3 times -4 to the 4th. I end up with 3,840 x y to the 4th. And then the last one is a -4 raised to the 5th, which is going to be a -1,024 y to the 5th. And then that's your answer. This is when we are expanding a binomial. Now, sometimes they want us just to find a single term. So if we're going to find a single term, this is kind of like the binomial probability we were doing the other day. So what we want to do is kind of pay attention to a couple of different ideas here. First, we want to know what term, 8th term, okay? Then we want to know the power we're raising it to. So we're going to take that power and we're going to minus that term. And we, just like when we are doing our series, and maybe we aren't adding from the first one, maybe we're adding from the 5th one or something like that, and we subtract and add 1, we add 1. So we took the power 13, the term we want, which is 8, and we subtract it, and we always add 1. And when I do that, I get a 6. Now that 6, what that 6 becomes, that 6 is the choose that we're doing. So here, I wrote it in this form, but this is going to be 13 choose 6. That's where we're at in Pascal's triangle, okay? So remember when I was writing these out with combinations, okay, if I was in row 13, so let's just pretend that this was 13. So this would be, for example, we'd have 13 choose 13, 13 choose 12, 11, 10, 9, 8, 7, 6. So, for example, that number, if this had been our 13s, would be what I'd be looking for, okay? So let me just erase this because these are not 13s. This is 11. Okay, so we are going to do 13 choose 6, which we would just put in our calculator. And then what we do is we take the first term, okay, the first term here, which is x, and we raise it to that power, just like we did when we're doing our binomial probability. Then we take the other term, which is this -3y, and we take that -3y and we go, okay, 6 plus what gets us 13? 7. Put that in our calculator, and that's how they got that number. Okay, so when we're doing this one, our exponent is 10. we want the fourth term, so we're going to minus 4 and then add 1. So that's going to be 6 plus 1 or 7. So what that means is I'm going to be doing 10 choose 7. Something to the 7th, something to the 3rd, because 7 plus 3 gives us 10. Now this first term is going to be 4x. The second term, you include that sign, is a negative 3y. And then we're going to put this into our calculator. So if I do 10 choose 7, just trying to get in my calculator. Okay, so 10 choose 7. That gave me 120 for this. Now I can put this all in my calculator. So what I mean by that is do 4 to the 7th also times that. So that's going to be 1,6,3,8,4 x to the 7th. And then this is going to be a negative 27y to the 3rd. So let me take 120 times 16,384. 16,384 times a negative 27, and I get a negative 5,308,4160. So negative 53,084,160 x to the 7th, y to the 3rd. That is our term. Okay, we didn't have to expand it all to find a single term. Okay, try one more. So in this case, we are exponent is 12. We want the 5th term. So we're going to go 12 minus 5 plus 1. That's 7 plus 1 or 8. So we're going to be doing 12 choose 8 times something to the 8th and something to the 4, because 8 plus 4 is 12. So I'm going to have a 3x and a negative 4. 3x, negative 4. So when I do 12, choose 8, I get 495. 3 to the 8th is 6,561 x to the 8th. And negative 4 to the 4th is a 256, because a negative 2 and even is going to be a positive. So if I do that math, 495 times 6561 times 256, I end up with 8314,09920. So 831,409,920 x to the 8th, and that would be our 5th term. So this is what your homework today is going to look like. So make sure you submit this, get your points, and you're going to be doing both of these ideas on your homework along with some review.